Good morning, good afternoon, good evening. Thank you for tuning in to Blender Studio S. Today I'll be going over how to make this text slicing effect using geometry nodes. Though the use case as a text effect can be limited, this technique can also be applied to regular mesh as well. And also, this tutorial will go over usage of repeat zone node group, which was added in Blender 4.0. So if you're curious in using them, this tutorial might also be for you. So, without further ado, let's get into it. Alright, so let's start slicing some text. But before we start, we will be using repeat zone, so Blender version 4.0 or above is going to be required. So as soon as we get into Blender, let's hop right into geometry nodes layout. A to select everything, X to delete. Shift A, add a mesh plane. Using numpad 7 and 5, go into top orthographic view. Click on new, delete the group input, and replace it with string input. Type something like test in here. Pass it through strings to curve. And output, like so. Alright, so today's effect is gonna be slicing effect. So just imagine a loaf of bread being sliced like this with uniform width, right? And what we're gonna do also is gonna label or index rather like this from left to right. So we can use these index for animation later. Okay. So first things first, let's fill the curve. Just gonna clear these. And since we are not gonna be using letter indexing, I'm just gonna use a geometry to instance node right here to combine it into one index, like so. So we only have one instance to begin with. Okay. I am going to be using mesh boolean to perform the cuts. So I'm going to be needing another object to act as a cutter. So what I'm going to do is pull this out, pass it through a realize instance, pass it through a bounding box, and pass it into a transform geometry. Okay, like so. So just to give you an idea of what I'm going to be doing, basically what I'm going to be doing is I'm going to use this cutter object, shift it over, make a mesh boolean, shift it over, make a mesh boolean, shift it over, make a mesh boolean, rinse and repeat. So that's basically the idea, right? So before we proceed to go with mesh boolean, let's take a look at these two objects. As you can see, though, they are both 2D planes, and Blender doesn't really take liking into doing mesh boolean with 2D planes, right? So what I'm going to do is actually extrude this mesh right here. So this cutter object is now a 3D object instead of 2D plane. And I'm going to be performing mesh boolean between this and that. Okay. All right. So before we do mesh booleans though, since the text is right now instance, I'm going to be realizing it. So it becomes a mesh. And I'm going to add a mesh boolean here. Keep it as a difference and plug it in, like plug these in like so. So since this is a difference, whatever that is not overlapping is going to be appearing right here, right? And since I'm only going to be using this transform in the positive X direction, everything that comes out of this difference node is going to be on the left, just kind of remembers that. Okay. All right. So I'm gonna Control Shift D and duplicate this, bring it down like here, and change it to intersect, and replug the realized instance into mesh boolean, like so. So this part is going to be the right side. Okay, intersect is going to be the right, and difference is going to be on the left. Left side, right side, left side. Okay. All right. Now what I'm going to do is join geometry and actually put it back together, like so. Right. So I'm just keeping it intact, and I'm going to make cuts all over the place and just keep repeating the process. But because we realized the instance here, everything is now mesh element, and whether it's on the left side or the right side is basically indistinguishable. So what I need to do here is add a geometry to instance between here and also between here. And so now we can see there is a left side and the right side, and you can actually see the cut right here, right? And in the spreadsheet, we can see there's a label or index for either left side or right side. But we can't really tell if left side is index 0 or right side is index 0 right now. So let's find out. Okay, so I'm going to add a separate geometry node right here, change it to instance, add a compare, change it to integer and equal, add an index, and pass it in like so. Okay. So as it turns out, index 0 is the right side and index 1 is the left side. And this is actually the opposite of what I want. What I want is to have the lower number on the left side and the larger number to be on the right. Okay, so why is this flipped, right? Well, if we take a closer look at join geometry node, and let's say we pull this guy out and attempt to plug it back in, you can see there is a subtle position change right here, right? Even though it's one socket, there are multiple positions you can plug it into. So what I want is for anything coming out of this difference to be plugged in at the top position, like so. So now if we take a look, we can see the left side is index 0 and right side is index 1. Great. So this is how I wanted it. And I'm going to be using the separate geometry later, so I'm just going to mute this for now and move it over. So we have been successful at splitting one text into two separate geometry instances, right? But we want to do more. We want to make multiple cuts, okay? So that's why we need to use repeat zone to repeat this process for later. Okay. So what I'm going to do is add a repeat zone node right here, kind of like in this position. Spread it out like so. Okay. I'm just going to kind of squish these together. Okay. And I will have to reconnect these lines. Okay, so this is how I'm going to reconnect. Geometry to instance to repeat input to realize instance, join geometry to repeat output, and repeat output to separate geometry, like so. If you did it right, basically the brown area is going to reappear. If it didn't, just make sure the connection is like this, like so, right? So if you did it right, it should come back. Okay. So, before we start thinking about which operations we want to repeat, I'm just gonna quickly add an iterator. So I'm gonna add a math node, keep it as add, bring a line from this empty socket, plug it into the top, add 1, and brings a result all the way to repeat output value, okay, like so. Select the repeat output, pop open the N panel by clicking N, and go to the node tab. Rename this value to something like iter, right? And change it to integer. So this iterator is going to keep track of how many times we looped, and we're going to be using that value as well, okay? So, what do we want to repeat? So in order to make slices, if we were to make a first cut here, if we were to make a first cut here, we don't want to keep on cutting the same position. So we want to, for the next loop, we want to cut to this position. For next iteration, we want to make a cut here, and so forth and so on. So in order to do that, we have to update this cutting position depending on the iteration. Okay, so let's do that. I'm gonna pull this result of add out and connect it to multiply. Pull this out, connect it to combine XYZ, like so. Kind of cluttering up. And connect the result of combine XYZ to transform geometry, like so. Okay. The multiplier here is gonna signify the width of each slice. So I'm gonna keep it as 0.1, essentially 10 centimeters, and the width of this grid. Okay. So each cut is gonna be 10 centimeters wide. If we were to increase this iteration count, we'll see that the final position of the cut, where it's gonna end up cutting. Okay. All right. So we are done with the cutter position, this part. So what about the top part, right? As I alluded earlier, for the first cut, we want the index to end up like 0 and 1, right? So here is a cut. So what about the next iteration? So the cutter is going to move over here and make a cut here. What I want for it to happen is basically this piece is going to be 1 and this piece is going to turn into 2, kind of like so. And for the next iteration, it's going to be the same. It's going to make a cut here. This index is going to be 2 and this index is going to be 3, kind of like that. And as for operation purpose, we only want to perform mesh boolean on this remaining piece, right? This piece. Since these are already cut, we don't have to make a mesh boolean right here. So what I'm going to do is pull out this instance piece by using separate geometry. Plug in before realize instance, change it to instance, add a compare node, change it to integer and equal, use index, compare it with the iterator right here, and plug it in like so. Okay. And I'm also gonna pull out the inverted, bring it all over to this join geometry. And mind you, there's gonna be 3 positions you can plug it in, right? The order matters. So I'm gonna plug it into the top. I'm gonna reroute like so. So ultimately what's gonna happen is join geometry is gonna have inverted at the top, difference in the middle, and intersect on the bottom, in that order. Okay. So now if I were to increase the iteration count, you can see there are cuts being made, and also the geometry is going to be increasing with the amount of cuts we make. Okay. And if I were to turn this separate geometry back on and go through the indices, we can see the index is increasing from left to right, just the way I want it. Okay, cool. As for the number of iterations, since we know the width of the cut, which is this value, and we can also calculate the width of the text itself, we can automatically calculate this iteration, right? So what I'm going to do is pull out this value and also use the vector mass node. Change it to subtract max from min, pass it through a separate XYZ, and using this X, divide it by the width of each slice, like so, and plug this into iterations. Okay. So now, if I look at this, the value is 15. So say for example, if I change the text to something shorter, it's automatically going to update, right? So now we no longer have to manually change the iterations. Okay, cool. So pretty much the cutting part, slicing part is finished. And I think you can make a lot of interesting animations by yourself, but I have to address one issue, so I'm gonna make a very simple animation, right? So I'm gonna use a set position here and combine XYZ, add a map range. I'm gonna use a scene time and index. I'll use the mass node, change it to subtract, another mass node, change it to multiply. I'm gonna pass index into multiply, scene time and multiply into subtract to map range. I'm going to change this map range value to 220. Pass this into combine XYZ, plug it into offset. Okay. So what this animation does is each piece is gonna basically slide in from right to left to its original position and end up as a whole text of this original text. Okay, so let's see it animate, right? So it is doing what I want it to do, right? Each piece is sliding in and forming the original text mesh, right? But if you take a look at here, the FPS is basically horrendous for the simple thing that we're doing, right? FPS is dropping like crazy. And let's try to figure out why. Okay, so if I turn on the timings overlay, we can see that the whole calculation per frame is taking about 200 milliseconds, which amounts to like 5 FPS, I guess. But why, right? Basically, the calculation that we're doing is pretty heavy. I mean, if you look at these two mesh booleans alone, it's taking about 15 milliseconds for one operation, well, these two operations, and we are repeating it 15 times, right? So it amounts to about 200 milliseconds by them alone. So basically, this number is legitimate, right? And that's how much we are doing, how much calculation we're doing. So we kind of have to accept it, but we don't want to, right? So we want to improve this. So let's kind of see what we can do, right? Basically, we are calculating everything right now, each frame. And the question is, do we have to calculate everything? And the answer is no, right? If we take a look at the node tree, the only thing that is changing over frame is this part. So say, for example, if I mute this set position and run the animation, basically nothing is changing over frame, from each frame to each frame. So is there a way to only calculate this this part for just one frame and not calculate it for the rest? And the simple answer is yes, there is a way to do that. And I'm gonna show you that. Okay. What I'm gonna use is a simulation zone nodes. And I'm not gonna go through what simulation zone does or does not do, but there is an interesting characteristic regarding the simulation input, which is anything that comes into the simulation input is only going to be calculated on the first frame and is not going to be calculated for the rest of the animation. So if I were to plug this guy into simulation input and reconnect the simulation output to here, what I'm essentially doing is suppressing the calculation on the left to be done only on the first frame. Okay, so let's see if it works. So if I go back to frame 1 and rerun the animation, this is how it looks now, right? No frame rate drop. The total calculation is under 0.1 millisecond, and life is great. Okay. I'm gonna be doing it like this, but there is one downside to this method, which is whenever you make a change in the node map, even just slight change, it's not gonna update immediately, right? The only time it's gonna update is when it goes back to frame 1. Okay, so I just went back to frame 1. Now the animation changed. Okay, let's say I change this value. I'll have to go back to frame 1 to reanimate to get it to calculate correctly again. Okay, kind of like this. Okay, but considering how many iterations that we're doing now, right? It's probably going to be over 150 iterations of this loop. There is no frame rate drop, and it's a great quality of life improvement, right? All right, so I think I'm pretty much done with making the node tree, so I'm gonna actually add a material like so. Pop open a shader editor. I'm gonna directly insert RGB into surface. Pick a lighter color. Change the world to a darker color. Change the color management scheme to standard. Go back to frame 1. turn off overlay, and I guess I'll let it animate. Oh. Alright. So, yeah, the text is all sliced up. We can actually animate this however we want. You can make it go from top to bottom. I like that. This is kind of cool as well. But yeah, let's take a look at what we did. All right, so it's kind of elongated left to right, but we can kind of think of it as 3 separate pieces. We have a section for preparation, we have a section for repetition, and we have a section for animation. All right, let's take a closer look. Going from the left, we are preparing the string to be cut. We're making a cutter object. We are pre-calculating the number of iterations right there. And going to the repetition part, we are moving the cutter object each iterations, and we are selecting which instance we want to cut, performing the Boolean and joining it back together. Okay. The animation part, you can probably come up with a better animation on this part. It's pretty simple, but this is a simple example for now. With this simulation zone, it's empty, but what I'm doing is suppressing the calculation on the left to be only performed on the first frame. So it's an optimization technique. Okay. All right. So just like that, this is how you make a text slicing effect. Thank you for watching. Thank you for watching the tutorial. I hope you enjoyed making the slicing text effect. With just slight modification, you can also make these random slicing effect as well. By the way, using repeat zones sometimes can be tricky even if you're not new to geometry nodes. It is usually easier if you construct one operation and build a repeating sequence around it. Thank you again for tuning in. I hope you learned something new and hope to see you next time.